Today we are going to look at simplifying radicals. We're going to define what a radical is in a moment, but first we're going to go ahead and talk about perfect squares. This is a list of the first 20 perfect squares. A perfect square is a number such as 1 times 1, 2 times 2, 3 times 3, all the way up to 20 times 20. You need to write this list down because these are numbers that will come up in this concept, and you'll use these numbers a lot in geometry and further math. A number made by squaring a whole number is called a perfect square. So take a moment, pause the video, and write this list of numbers down. Okay. So you've got those numbers written down. Let's define a radical. A radical is an expression that has a root, like a square root, or a cube root, or the 10th root of something. Now what we want to do is we want to be able to estimate roots first of all, or estimate radicals, and so the first thing we're going to look at is estimating the square root of 23. Well, if we go back to our list of perfect squares, 23 falls in between 16 and 25. And what we know is this. We know that the square root of 16 is 4, and the square root of 25 is 5. Now because the square root of 23 on the continuum between 16 and 25 is closer to 25 than 23, our answer then is in between 4 and 5, and so a good estimate might be approximately 4.8. Now, we want to be able to simplify radicals in this. So let's say we have the square root of 196. Well, the square root of 196, if we go back to our list of perfect squares, square root of 196 is in our list. And the square root of 96 is equal to 14. Notice when I take the square root sign goes away. The square root of 256 is also in our list of perfect squares. And 16 times 16 makes the square root of 256. So what if we encounter a number such as the square root of 40 that is not a perfect square? Well, we can estimate, but what we want to do is we want to simplify the radical. So the way this works is we're going to see if we can find a number that's a perfect square that goes into 40. So if we go through our list of perfect squares, we find that 4 is a perfect square that can be divided into 40. And 4 times 10 gives us 40. Now, we know the square root of 4. The square root of 4 is 2. The square root of 10 does not have any other perfect squares in it, so we leave it. And we read this 2 times the square root of 10, or 2 square root of 10. This means the same as the square root of 40. Here's the square root of 27. It has a perfect square in it of 9. And 9 times 3 is 27. Notice I put both of those underneath the radical sign. Now we know the square root of 9 is 3, but we don't know the square root of 3. So we write this as 3 square root of 3. Now the square root of 14, if we look for a perfect square in 14, the only one is 1. Now you're thinking 2 times 7. Well, we don't know the square root of 2, nor do we know the square root of 7. So what we would write for this particular one is the square root of 14 is in simplest form. It's the square root of 14. How can we simplify fractions underneath a radical? Well, let's take 49 over 225. If we break this into two radicals, the square root of 49 and the square root of 225. Now, you can do that because it's a division. We know the square root of 49 is 7, and the square root of 225 is 15 times 15, which just becomes 15. Now the square root of 181st can also break down into the square root of 100 and the square root of 81. We know the square root of 100 is 10, and we know the square root of 81 is 9. Both numbers in the fraction were perfect squares, but what if they're not? What if we had the square root of 5 over 36? Well, this is the same as the square root of 5 over the square root of 36. We don't know the square root of 5, so we leave it be, but the square root of 36 is 6. We read this as the square root of 5 over 6. Here's the square root of 10 over 169. This can be broken down into the square root of 10 over the square root of 169. And we don't know the square root of 10, so once again we just write the square root of 10. But we do know the square root of 169 is 13, and if you don't know that yet, you will with the more practice you do with this. Now, we know from multiplication that 5 times 5 is 25. But what is the square root of 5 times the square root of 5? Well, if we multiply these together, we multiply the numbers underneath the radical and get the square root of 25. And the square root of 25 is 5. And hopefully you see a pattern that the square root of 5 times itself is just 5. Now that pattern is important because what if we have the square root of 71 times the square root of 71? We really don't want to multiply the numbers inside there too bad, but if we look at our last pattern, the square root of 71 times itself is indeed just 71. And this concept will be really important as we do the next part. What if we have the square root of 36 over 5? Kind of like what we had a moment ago, but it's the reciprocal. We make this the square root of 36, and we make it the square root of 5. And like last time, we knew the square root of 36 was 6, but we don't know the square root of 5. Now, we have to simplify this because we don't want to keep square roots in the denominator. So what we're going to do is we're going to multiply the top and the bottom by 1. Because the square root of 5 divided by the square root of 5 is really 1. So when I multiply the top, 6 times the square root of 5, I can't multiply them together because one's inside and one's outside the radical. But the square root of 5 times itself on the bottom just becomes 5. My answer is 6 square root of 5 over 5. Show you one more like that. Here's the square root of 25 over 6. And we're going to break it into two parts again. The square root of 25 is 5, and we don't know the square root of 6. We have a square root on the bottom, so I'm going to multiply the top and the bottom by the square root of 6, always the denominator. This, in turn, is going to give me 5 square root of 6 on the top, multiplying, and the square root of 6 times the square root of 6 is just 6. So far, with fractions, we've seen that if we have a fraction, which we know we can split up, like the square root of 6 elevenths is the square root of 6 over the square root of 11, one of them has been able to be simplified. But what if it can't be? Well, if that's the case, we'll multiply the top and the bottom by the denominator. So the square root of 6 times the square root of 11, this time we can multiply the numbers inside. It gives us the square root of 66. The bottom is 11. Sometimes we have to simplify the numerator. In this case, we don't. Our last one is the square root of 7 over the square root of 2. Once again, we don't know either one of those radicals, so we'll multiply the top and the bottom by the same thing. This gives us on top the square root of 14 and the bottom 2. We can't simplify this because 2 can't go into 14 because we have a number in the radical and one that's not. Okay, independent practice time. We want you to go ahead and do the next 7 items that you see next. So pause the video and then we'll be back in a moment with the answers. Okay, so estimate the square root of 70. The square root of 70 is between the square root of 64 and the square root of 81. 70 falls kind of more towards the 64 side. 64, it becomes 8, and the square root of 81 becomes 9. So the square root of 70, a good guess for it, might be somewhere in the neighborhood of Well, maybe about 8.3. Our next item is the square root of 324. 324 is a perfect square. It just becomes 18. But the square root of 75, does it have a perfect square in it? Well, it does. Namely, 25 and 3. 3/4 makes 75 cents. Notice I always write the radical first that can be simplified. The square root of 25 is 5. The square root of 3 we don't know. And I leave it like that. So you can use the concept of factor trees, which you've done a long time ago with simplifying radicals. The square root of 9 and the square root of 29 are both perfect squares. Becomes 3 over 17. The square root of 6 over the square root of 81, one of those is perfect. And that's the square root of 81, which is 9. Finally, the square root of 100 and the square root of 7. We know the square root of 100 is 10. We don't know the square root of 7. So we'll multiply the top and the bottom and get 10 square root of 7 all over 7. Our bottom one, square root of 3 over the square root of 10. Neither are perfect, squares that is. So we're going to multiply the top and the bottom by the square root of 10. Gives us a square root of 30. Now this is the square root of 100, but we know that that's just 10. Rewatch the parts of the video that you need, as there's a lot of different intricacies dealing with simplifying radicals. We'll see you next time.